Okay, that's good. So, how are you guys? I guess you got a Monday off. So hopefully this week is not so tired compared to last week. Uh, so let me quickly review what we have done in the lesson one, because we have still have one graph haven't done, but this graph actually related to lesson two anyway. So we'll quickly review what we've done. So last class we basically talked about the data. Okay, it's important to collect data and ensure the data quality. Okay, and just to remind you that these are all the Python's thing. I guess I haven't uploaded the Python slide, but I'll upload Python slide so that you can take a look at what kind of stuff that will be covered in the overall class. And also, in particular, we talk about how to, in particular, we do again is we learn the Python and go into the Panda, right? And import is to load Panda as the short form Panda, and then this is Panda as a function that actually read the CSV file directly online, right? And then the head will be just reading the thing, and we learned that the filter is to set the column, okay, and so on and so forth. And I'm going to over all the slides, but data quality is important, and it's hard to teach you how to clean up the data in this class, but do remind you that there are many ways to make sure that your data is representative, because the main idea of using the data is to extend the knowledge from the data to a general purpose, right? So you need the data to be a good one, and then you have to make some changes to that as well. So after that, we in the chapter 2, we talk about how to prepare data for analysis, because you often download data from someone else or from the database, and very often the data is not in a nice form. For example, the data is not in the nice format, usually in the long format, right? And then we tell you how to convert them into a wide format. Okay, just to remind you, so the data is like this, right? The immunization data, your country and year, right? This is usually you see from database, but this is not good for analysis. Either when you look about big data or when you looking regression, it's not going to work out. So instead of that, then we will just try to transform it to this type of data, right? And that would be using what we call the index and unstack as a way to make the data from long to wide. And then after that, we write the column names from multi-index to single index, okay? And that is what we cover. And the first thing we cover last class is how to combine different tables, because you download data from various sources and then you need to combine them together. And we combine in the way of using the Python code. So that's very important, because the classical procedure, maybe people work with Excel and you combine, copy and paste, then that is not a good way to do it. So everything should be documented. So data processing should be documented through Python. So even though you download data from the Excel spreadsheet someone give you, you shouldn't touch the data. You should use the Python to handle it. But why? Because use Excel, then you lose track what you have done. And it's not easy to compare. But when you do Python, you pretty much clearly know each step what you're doing. So that's very important. Especially you want to do serious data analysis. But of course, I guess you guys are IT manager. I think the company would don't allow you to change the data directly by your hand, right? Unless you are you're this company CEO, you can do whatever you like. But otherwise, I mean, you have to follow some procedures that exist in the company. And at the end of our last class, we talk about this football manager case, right? And try to combine games and teams and manager data and try to find who is the best manager and best in terms of number of points per game is the largest, right? When they win 3 points, they draw is 1, and they lose they 0. So the average point that is largest is a good manager, right? That's what we define. And I think we talk about how to do that, and we sort the data, and we try to learn how to read the data. And we said because in interest of time, we directly handle the final version of data. Okay, but how to get this data is also important when you actually do the project. And we learned one important word called group by, because we want to calculate for each manager in each team how much point they get on average each game. Okay, so that's why we group by that. Probably ask, is it the same? Yeah, I mean, you don't have to do both because usually they're the same. So sometimes the team and ID should be fine. But for exposition, then usually you put 2 doesn't really harm anyway, unless your data have some error such that the ID and the manager are not coincide. Then otherwise you should be fine. And we see that by using group, and another important term called AGG is like the pitfall table. Aggregate that, okay? You sum of the games, and then you also calculate the points, okay? And then after that, you join the 2 data set by join, okay? Once you create that, then it's you create a data set have games and points. And now what the next is, you create a new column that is the average point per game. So you divide this column by this column, right? So that's how we have this thing is creating new column. Okay, this is a new Python code, okay, that you learn. And because you want to find the top 10 guys, so you sort it the data set, then the first 10 row will be the answer, right? And also they will figure out that there's one guy play one game, just one is not something we want to see. So that's why we try to filter the data based on the number of games they play, and then we want them at least play 18 games. And then once you clean that out, then this is the data. Okay, so I guess that's pretty much we stop here, and basically stop in this one. And possibly what we want is to show you how to visualize the data, right? And this is actually part of our topic 2. But before we do that, maybe you go to the code lab and show you the last time where we stopped. Let me sign in my account. Did I forgot my account? Let me give me 1 minute. Let me check a little bit. Sorry for a delay because of the Google have very strict AI thing. Let me open the file that we do it last time. I think. Let me check the last time what we do. I think this is our last time, I think. Yes, this is the one we did last time. So we go to the where we end, we run this thing. This is the top 10 candidate. So what we want now is to want to have this plot to illustrate that graphically who are the top 10 manager and how many games they win. Okay. So how do you do that? We will use a library, which is basically the main library that you draw 2D graph. Okay. And that is called the Matplotlib library. Okay, Matplotlib library. And because we draw a 2D diagram, we will be using the Python plot. And we import this as the plot. And we use this in this chapter 2. We often use this one. So to define the plot, usually you have to tell them what is the size of plot. It's 10 by 6. You can adjust this number to fit your need. Okay, doesn't really matter for this one. The key is this one. The key to plot this is you're going to plot a bar chart, and the bar chart is growing in this direction, so it's called the horizontal bar. Okay, if you remove that, there will be vertical one. Okay, and how to plot it, you tell them it's manager plot, so it's XY, right? Based on manager and the plot. The points is on horizontal. And here it's very simple. We have a X label, right? X label is the points, X label points, and Y labels are manager. Okay, and then you tell them the title of the plot, and then you want to show them. Okay, so they will display. So we explain line by line. Okay, but don't worry, we're doing more plot today. But for the moment, let me just copy and paste because I don't want to spend time on typing. But the copy and paste doesn't look well. So just need some edit. So this will but I guess a little bit weight, but and you see it doesn't show up nicely because I have to import the data from here, starting from here first. So I have to run this code to download data again because from the web again, and then let's run it. So don't worry, it'll be fast. Run all the lines again from here to here. Okay. Did I miss one last line? I guess. Okay, I missed this line. So what it do is I have to take out the 10 managers there and took that point because I just need that for my data. Okay, so that's why I need this line to run first. This is I sort the winning ratio and I take the first 10 guy to the top 10. So this only we keeping the 10 guy. Okay, so let me get it out because I missed that line. Okay, I have to run this line, this code. So once I run it, you can see this is how this graph is doing. Of course, as I said, if you don't like the edge, you remove this, become vertical. Okay, but why I don't like vertical? Because the name here doesn't look very well. So that's why for exposition reason, horizontal one become the good choice of the graph. And also the point is very natural in this dimension. Okay, so I guess this pretty much I should have said in the last class, but we don't have time to do that. Just to remind you again, please make sure that when you download data, you have a README file to locate, to tell very carefully where the data comes from, and you have the raw data that you download that from. The clean data is the thing you use the Python code or R code to clean it up. Okay, and make sure that you have variable description. Okay, and then once you clean, you do analysis for other folder, which we'll discuss very soon. But now we didn't do analysis. We just have the raw data and clean it up. Okay, so that's what we have. Now, once with that, now if there's no question, then I will go to lesson 2. Okay, lesson 1 is done because I just didn't have time to go over this particular bar chart for you, but we'll cover more bar chart today. Okay, and today's goal, as you can see, we're ambitious, 168 slides. I mean, probably you will see that we may not be able to go through every single thing, but you know what I skip. But mainly at the you can see most of the slides are coding. Okay, so don't worry about that. It's not going to be something like too long. But I will say I will not type out every single code, but it's already in the code lab, so it should be okay if I don't show you the detail by typing out. So what we do today is 2 things. We'll do chapter 3 is called exploratory data analysis, is EDA, and the second is called correlation. So I start with EDA. EDA is just trying to get information out of data, and you learned it in the undergrad or a lot of basic class of statistics, right? So that is the first thing you come with your mind to get information out of data. Come on, mind is what? Is mean, median, mode, right? Central tendency measure. Second type in your head, probably I guess is standard deviation, right? Variance to measure dispersion. What are they, right? Suppose your client, your boss would ask you, okay, you get the data, you tell me what's about, right? If you trying to use a single word or single number to represent data, right? A variable is use mean, median, or mode. One of them depends on data you have, right? And your boss or your client continue to ask you how good is the number you give to him or her. Then you would reply by standard deviation, variance, or other dispersion measure, right? Coefficient variation or interquartile range, this kind of stuff, right? So these are numbers. And of course, there are other further measure the data are symmetric or not, whether they have a lot of fat tail or thin tail, but that would be something you would have done, right? To tell the basic information. And this single number will be very useful. We'll talk about that, how to do it in Python, right? But it will be easy to implement those. But of course, as we just did, one of the very useful thing because of the computer is visual. It's a table and graphics. Okay, that's what we do. We show you Python how to do this kind of visual graphical analysis together with the number analysis. So these are the number that you try to crunch out before you go ahead, right? Because what you do is for each variable, you try to crunch out what they are, right? Look at the mean, the variance, and look at the distribution, how it looks like, right? And after that, you would try to look at, in the chapter 3, the chapter 4, look at correlation. You try to look at different variables, how they're related, okay? And when you look at how things are related, the simplest one is correlation, right? Because it's just looking at linear relationship of what they are. And if you learn statistics before, right, correlation form the basis of regression analysis. which is the main tools that are used in statistical analysis, right? And just to warn you again, is correlation doesn't imply causality, which will be the second half of our course. Just showing two things are related is not done yet, right? You have to need to learn new things in order to say they are related in a causality manner, right? Because you want to know if you do this, this is my effect, right? So this is something what we want to establish at the end of this class. But before we do it, we need to describe the data of single variable and how different variable related. So that is the goal of today. And of course, I guess most of you have learned all these things in the undergraduate. I mean, whether you remember it or not, or you do it in your job, but what we're trying to do is to do everything in Python. So that's make sure that you have a hands-on experience on how to operate them in Python. The thing is that the math behind, I would probably just very quickly go over, but I guess the math part is not very important because you have exposed to this idea before, right? So the details should not be something worry about that much. You can pick up very quickly. So let me say with the Python code of this class already there, we can click that because of time. Probably I would just also do that the same. Well, I'm not typing every single code there. You will be there, so we can just run the code rather than I copy and paste to save time. Because as we said, we have 160 slides. Okay, so we have to be a little bit faster. So I'm not going to type it out and copy and paste, but you know you can copy and paste by yourself. I copy and paste. I do Control-C, Control-V for you here, but you can just download that. Okay. So now let's start with the why can't I full screen that? Yeah. EDA. Okay. The EDA, the important is to describe the variable, and then you may ask why we care about that. There's several reasons because you check whether data clean correctly, and you get some sense of what data they are. And very often you need to check whether the data is consistent with existing knowledge. Okay, and that's very important. Very often you have to check whether the data is doing right or wrong because there may be something happening in the background. And there's often the case, even the computer have problems, programming code error, end up with the data you have. So have to be, every time this has to be checked. Okay. And you can ask some simple question based on data. Okay. So that is the reason why I do EDA. And what you can do is look at EDA, where the extreme values and how the state looks like and so on and so forth. And the main tools for EDA are two, as I mentioned just now. One is graphical, one is descriptive. And both of them you learn. Graphical, we start from kindergarten. We start pictogram, right? Bar chart, pie chart, all those things. And descriptive statistics, you learn that in some of them in high school, some of them in the college. So these are the things that you know very well. But of course, some of you may not remember it. That's okay. So we just remind you those. Okay. So to start, we have to define a term called frequency. Okay, because this is how we plot stuff. And frequency, there's two ways. Absolute, one is relative. Absolute is something we do all the time. You count 1, 2, 3, 4, 5, and the graph just shows exactly absolute amount. Okay, this is usually we do in practice, but when we look at the shape or when to compare across data set, then the relative is better. By relative, it means that it's just the absolute over the total. Okay, just percentage. Okay, so suppose I will ask how many people come here by bus, how many people come by train, how many people by drive. The absolute number will be the just how many of you. If I look at percentage, relative means 20% of you take the subway and 10% of you drive and 35% of you by walk, so on and so forth. And you will see absolute is good to see what's going on there, but relative is good to compare across. Look at the trend is very useful. So you see the Python code will also automate this process very soon. You will see. Okay. And we'll focus on for today's class, we focus on histogram and density plot. But you can, if you have time, you can look at a lot of Python tutorial or the data cam that can tell you many ways you can plot stuff. But we just focus on these two in our class. And I think that's most useful one. Okay. And once with this plot, then you would want to check out several things, right? You want to look at the mean, median, or the mode, right? As we have said. And we also look at the spread and the shape. Are they spread out? Are they symmetric? Are they thin tail or thick tail? Look at whether the extreme value. So let's see the graphics, right? The graphic have two things, either the graph or a table. And turn out maybe you think graphic is the dominating, but sometimes, I mean, table is also very useful. So, and there's some guideline on how to have a good graph and good table. I guess this is very immediately clear. I'm not going to go into details on this. Instead, I want to go to Python directly. Okay, that would be more fun because that is something we want. Now, remember the chapter 1 or the first class we do is look at the first example is the price hotel booking.com, the hotel data in Vienna. Okay, so what we're going to do is looking at this again. We do a plot on this Vienna prices, and also we will compare this to the London hotel price. Okay, we're comparing contrast. So that's what we're going to do. The data is the same, so nothing new there. Same data set. Okay. Now let's do it line by line again. Okay. So first, I have a new line here. Okay. It's called NumPy. Okay. NumPy is a package where Python can do calculation very quick. So this later you will see this will be very helpful to create things for numbers. So you will see this very often. NumPy, okay, is data handle number. And Panda, as we know, the Panda is the package handle data. Okay, and we have this same Vienna data, and we use the Panda CSV to import the data. Okay, and the next thing is remember this data has a lot of category. You have hotel, apartment, you have mansion, or many things because we're interested in doing a sightseeing holiday. So we only interested in hotel. Okay, and what we do is we are filtering, okay, through the hotel. Okay, and some of you asked me after the class whether I need the LOC because if you try to do the code without this would work. But I would say yes, it will work. But if you have multiple things to do, multiple operation together, and if you don't have this, the code become unstable. So that's why I always recommend as a practice when you try to subsetting the data, selecting observations, always use .loc to get the data out. I mean, you can try without that, you should still work for this simple example, but you may have some issue when you ignore it. Okay, so this is the data. Okay, in case I just run it because we have the data already here, so I download data. Okay, let me wait a second. He's just connecting. Okay, so I think just a few seconds there. That's done. So once you're done, you download here. You want to take a look. Okay, this is a data set here, and as I said, you want to take out the hotel. So what this thing that is inside the LOC is saying that, okay, I'm trying to check whether a common is hotel or not. When the equal, there's a logical statement, okay, it's telling that if hotel is 1, non-hotel is false or true or false or 0 or 1, right? So once we have that, okay, that's what you do is I try to call a hotel, which I look at data set, and I select based on true and false. If they're hotel, right, then I just pick it up. Okay, so basically what I do now is I select the hotel. Okay, so once I run this and I run it, then everything is hotel data. Okay, look at the last column, everything's hotel. Okay, so that is just to remind you, if you put 10, then you have a 10 line there. Okay, so the hotel is there. Okay, so as we said, I mean, we're trying to look for the deals in the booking.com, right? So that means that we want to look at how the price looks like. Okay, so we start with histogram. Okay, and because why histogram, not bar chart like we just did before? Anyone want to say why we use histogram, not bar chart? Yes, because bar chart only for discrete data, right? You have we have C manager, then you can use bar chart, and because of this price is continuous variable, you have to cut it into multiple parts, and it's continuous variable, as we said, distribution there, so have to be histogram. But of course, we say, okay, histogram and bar chart are the same thing, right? Because one is discrete, one is continuous, yes. But this is how we call it, okay? The histogram. And because the price is from 0 to, say, 1,000, right? Then how do you draw each bar? It's called a bin, okay? And how big is, once you group it, is we have more choices, but we can try 10, 20, 40, and 100, okay? And by how do you create this thing is we'll use the B.B.A range, okay? It's something a little bit not easy to see, but range by Python is just creating list of numbers, and I don't know why they call it a range. Would be just based on this and create set of numbers. You will see it very soon. Okay, but this is from the NumPy package. Just create some numbers. They call the bin number of bins. And after that, we use the doc.hist to create histogram. Okay, and we remember with X label and Y label to label and have title. Okay, so that would be the thing. The one we have seen, the bar chart will be bar H. Okay, but now we have hist. Okay, so what we're going to do is to, from the hotel data, we take the price column and copy out that save as the price variable. Okay, and here we have created a bin. The bin width is just, say, you can use 10, 20, or 40 or 100. Okay, we're going to do the bins will be starting from the minimum price to maximum price. That's a little bit weird code. Have to be careful. Is because of the way the Python create the range. You have to be maximum plus the bin width. Okay, this is just the way that this function is being done. So and bin width is how big it is. Okay, so basically what you do is from the smallest to the biggest prices, you cut every this interval by the bin width you impose. So every $10 is a bin, and then you can measure it. Okay, let me run the code to let you know what's going on there. Say so here's the code. I run the price. Okay, and I have 10 bins here. I use 10 because that's what in my slide. Okay, and to show it better, maybe I just copy this guy out. Okay, and I show you what the bin actually inside. Okay, so you can see the lowest price is 33. Okay, so this will create a list of number starting from 33. Every time you increase by 10 until you get to the biggest number and you go to by 10. Okay. So that is how we create a list of numbers. Why I want to do that? Want to do that because the Python is very smart. Okay. Remember this line we have just saw? This is the line that you import from the plotting library, okay, and two-dimensional plot. And you tell them histogram. The histogram just all the prices, you could count them. You tell them the prices, you tell them how you're going to count them, right? So you can look at the beans here. So you just look at this, look at the price data, and you try to see, okay, if the price is within this range, you put it inside, and so on and so forth. Okay? Then just do the counting. Okay. And once you do this, okay, and tell them the label of X, label of Y, and a title, and so we give you the this histogram. Okay. And you can have fun. Suppose you don't like 10, okay, and you want it to be 20, which give you a different shape. Okay. Have some idea what it looks like. Once you run this, okay, this will be the diagram, right? And you can see, okay, what kind of the graph looks like the shape. Okay, at least you will see somewhat here goes up and goes down again, and there's a lot of big number there. But you can see center around 100 something US dollar. Okay, but the shape is also like symmetric a little bit, but there are a lot of huge numbers, very big. Okay, and also you would continue to work it out, like suppose I change to 40. Okay, and then you will see, okay, this is another graph. Okay, same shape. Okay, and then you can go a little further, maybe 100. Okay, and then once you do it, it become this just go down. You don't go up. It just go down with the shape. Okay, and you have some idea what it looks like, right? So look at this. Genetically, is you can say most of the price is below 200, right? So around 100, right? No more than 200. So that would be a easier thing to see. So that would be the diagram when I have 10, 20, 40, and 100. So you can see the shape changing along the way. Then you can tell some story based on the graph only by itself, right? The graph can tell a lot of story, right? And what do we learn from this in particular is if you group by 100, seems to lost information going up, right? And if you group by 40, seems like this is not so symmetric, right? But if you have 20, is also very good because it seems to show a very interesting pattern, right? Because suddenly go up a little bit again, right? Just go down and go up a little bit, say snail shape. Okay. So really depends on what you like. But that is what we have in the diagram. Okay. So this is one library. Before the break, I want to introduce you another library that is a front end for the Matplotlib. It's called the Seaborn. So Seaborn is an add-on on the Python if you're Matplotlib, but the Seaborn will build up on it, okay, and add to it, then make your code even easier to understand. So let me show you let's see the code here, okay, and the code here seems to be easier, okay. The code is like this. You call this package Seaborn SNS, and what we're going to do, of course, do the same. You have to create the beans, but once you have this histogram plot, you save it as access, okay, and you set the label, Y label, the title, and show it. Why it's good? Because the graphic look nicer, and you have many ways to make it look very beautiful. Okay, so of course, what I meant is if you want it to be very fairly standard to internal report, then use Matplotlib is sufficient, right? If you want it to look very nice, a professional marketing style, then the Seaborn will have a very nice one. Of course, I don't show you the most nicest one. You can go to the gallery of Seaborn and can check out very nice diagram there. But I'm trying to show you that it's possible to make it look very nice. Okay, even this one is way better than Excel graph, right? I hope you agree. I mean, maybe our different tastes, but I would say this is way better than Excel. Okay, if you think otherwise, I'm sorry. So we can't have same language, but it's okay to be different, right? But the C bond is not much nicer and more flexible there. I just run this code for you. So this is the code there. I just run from the scratch. This will be a very nice one. And I said there's a lot of thing on the web. So this is the Cbond package, and you will able to see they can create very professional diagram there. Okay, but I'm not going to go into every single detail on it. Is you can see even this can be not very nice, and you try to you can create this kind of very complex diagram, and there's a lot of things you can do. But I'm not going to go to every single detail because it's not a plotting class. But just let you know there's something there, or if you want, you can go to DataCamp. They have courses that talk about how to do the plotting. Okay, but I'm just telling you that how you can do it very nicely. Okay, so I think it's good time to the break. After break, we'll continue our journey and see how the plotting help us to understand certain problem. Okay, so let's have a break of 15 minutes as usual. And I will open the you reply for you to leave any message you want.
Yes, I saw there's the two presentation. Two presentation day report, but I may be out of time. Can I choose?
I haven't. We can only decide when the makeup when the airdrop is over. So which is next week.
So
we haven't decided which days. Yeah, we haven't decided which day. Because you will do at least one of them. And if you have,
I may be out of time.
If you have a reason, you can absent from that, no problem. So you submit the proof that why you are not bad, then your presentation score will be determined by.
But this is a group project.
The group project, but you have to convince your groupmate to do it for you. You don't have everyone to present.
Yeah.
If you assign to them, so it's not, or you can swap to other time.
Can swap the day.
Yeah, so they can swap. We will random, and then if you can ask for swap. That's okay. Okay. But if you think you are not presenting a big group, then I'm not asking everyone to present. So if you trust your teammate, then it's okay. If you don't trust, then you can present.
Okay, thank you.
Even if you don't present, that's okay.我未訂嘅，要呢個 add job 完之後，我先可以 announce，咁就要大家決定大家計數邊組，我就 draw 大家嘅時間。我會 draw 你哋可以 swap 嘅，因為公平起見，如果咁邊個揀先就好有問題㗎。咁我就大家可以抽籤抽個先。嗰個係禮拜二咩？應該係啱我寫錯，呢個都係堂上，都係堂上。但係嗰個冇個，即係我寫咗25，可能寫錯。但係應該寫錯。因為我唔係，應該係上堂。上堂上嚟。應該係13未10。我以前考試喎，但係考試我考1個鐘啫。哦，所以其實你係寫錯，因為你寫咗25。哦，唔好意思，13冇錯。sorry，唔好意思。哦，OK，唔好意思。我1秒。XD data 即係話
你係每一個都會係佢嘅好似自己個。就係話你每一個 observation，每個 year 都有呢個第一個咩係啦，係啦咁 stable。你其實可以用兩種方法嘅，第一個就係咁樣儲存 long form， 即係每一年都有。另外一種就 Y form， 咁就頭先我呢個啦。呢個 X 每個 variable 係就係。呢個唔係我老作計算，我冇老作出嚟。因為到時20嘛，咁你就計下加晒幾多個。你其實擺邊個都嘅，因為佢冇 missing 啊嘛。你塞邊個都計下有幾多啫嘛，即係話你捉咗個 manager 出嚟。咁啊，睇下你係 group by 呢個人噶嘛，咁計下佢有幾多個，玩多幾個人，玩多睇下幾多場波啫嘛。你呢個
真係冇乜定嘅，其實呢個
冇㗎，即係你 count 呢個得㗎 ，count 都得㗎 ，size 係數咗幾多個啫嘛。你呢個 variable division 你對咩都得㗎，因為你係數咗幾多行啫嘛，你數咗第一行啫嘛。
係啊，呢個
係啊，呢個係一樣嘅，照數啫嘛。嗯。今日教嗰陣時6個鐘啦，已經6個鐘，已經6個鐘，而家係第幾個鐘啊？第7個鐘。
因為考試咧咪會有計數嘅，咁咪可以拎計數機入邊。
計數機得，
需唔需要計數機？
會你乘啊加啊，應該唔使啩。如果你會帶咯，冇所謂。佢加減乘除啫，冇乜嘢㗎啦。
都係可以拎自己碌屎。
係咯，有啲電腦乜都唔可以帶電腦咯。呢個因為都係咯。
我啱先講邊嘅嗰個 chart 嘅嗰個 folder，因為佢嗰個邊細呢個。
係呢個。
但係其實佢
咯，佢闊即係你 group 大一齊㗎嘛，100每100個埋一齊。而家8個。
佢哋由邊度開始？即係
又加咯，
加個
33加8加8加。咁呢個咁樣33到133，咁咪會第一個邊度咯。
所以條巴係中間係有空嘅，冇黐埋。
因為 pixel 佢講啲要求嚟，如果佢係有空隙嘅咁就叫巴塞，冇空隙嘅就 pixel 嘅巴。
咁點樣睇邊個 interval 比較？
我睇個人興趣，然後呢個係睇點樣你想講咩 story 咯？你想話佢越遠越平，越即係好多係好平嘅，咁樣咪 好多啲大綱嘅，咁你咪100咯。你想講個 story 係比較認真嘅 story，咁你咪用10咯。因為10雞都有啲，咁真係有啲好平噶嘛。咁你想睇講咩 story 咯？咁但係其實呢個係比較好嘅，書都係咁講嘅。因為佢係睇到有個 friend 嘛，即係有好平嘅又好少，咩個中間比較睇得出個效果。
後邊嗰明星嗰啲
我可以 cut 咗佢嘅，我就可以 cut 咗佢，因為你覺得係啲人 outline 啊，你覺得 outline cut 咗佢咧？因為係咯，就係睇你嘅用途係乜咯。係開始有嘅興趣，但係佢嗰時學生都係呢個好多 data，有好多無限多 data set 嘅。
我以為要自己做 research，
買好多呢啲 data set，係中意攞咩咧？咁多人做 data set，即係你想揾乜都揾。有 music 啊，有呢啲咁嘅鬼怪嘅嘢，同埋勁多 data set 嘅嘢。即係你淨係想攞呢個玩得㗎 ，match 收啊，啲 team 啊，啲 financial market 多 data set，即係你可以應該揾到你想玩嘅嘢我諗。
有啊，
足夠你咁多，真係我諗佢都應該夠玩㗎啦。我諗呢個網站咯。
咁有冇話佢幾多個開始？你依家其實
你幾多可以做㗎啦？你先下 data 先啦，將我嗰啲曲隊落去 run 一 run 咯。你揾下你諗下自己想做啲乜啦，即係你想問個問題係咩問題去做咯。唔一定要用晒我上堂所有嘅嘢，但係呢個係俾你去應用下 Python 嘅嘢去做個 analysis。佢而家你揾下喺建議喺個網頁揾下咯，有無限多 data， 上網得㗎。Google
有冇問題？唔該晒。
So we'll resume in 2 minutes. If you want to fill in, feel free to fill in. Otherwise, we will resume in 2 minutes. So I guess I can resume. Just a very quick announcement is I guess it's about the some of you asked me the project, right? I think I have a typo in the days in the project, right? The project presentation will be I don't know why it doesn't show up here. So the project will be presented on the last 2 classes. Okay, I mean the typo for it is will be on the last 2 weeks, and some of you asked me how can I do it last week? Because last week is not exam. Exam only lasts for 1 hour, so the other 2 hours will be presentation. Okay, 1 hour exam will be easy, right? You don't have to suffer for too long. It's open book, so don't worry about it. Huh? I would not say difficult or easy, but I can't last year, but you ask full-time student, it's not that difficult.
What is the mean of solar?
83. Yeah, 83. Very low 5, I guess. I think when I teach the full-time course, the exam almost everyone get very good grade, but only difference I can see is from the project. Very clearly, this very clear description itself. You're not. No. You can try to be my first student who failed. Very hard. You can challenge that part. I never do that, but if you attempt to do everything nicely, then shouldn't be. So I saw this one. Let me show the result and see. I need a group. So if you're a group, please find. You don't have find someone in a group, but I guess the maximum size of the group is 7. So you can try to form a group, and also you can be on your own, so that's okay. You can be individual. Can we go through the slides slower? Is it fast still? Okay. And so far still catch it, that's okay. Tired. Yes. Slower. I don't know which part you want me to slower, but I think I'm slow. How do you go? 7. I typed A rings wrong in slide 14. Yeah, I think that's the case. It just is A. Yeah, this 1 hour, no 2 hours. Sorry for the typo. I think the code is correct. Yeah, code is correct though. So just the typo in this slide. And thank you very much. And yes, everyone got it right. And well, cloudy, maybe. I don't know. Yeah, continuous data and discrete data is going to be there. The code lab. How do you generate the chart in code lab is via image. I guess I don't know what you say, but I guess what you mean is you want to save this as a picture. I guess what we mean, but if I'm wrong, then let me know. You just right click it and save as image, and you will save. I don't know if this is what you want. If I'm wrong, let me know, but I guess what's what you want. Yeah, I'm making a graph, I guess. The lecture is okay, I guess. I think most of you still easily follow. Oh, I noticed a doctor. Just let you know I'm a doctor, but not the medical one, but a philosophy one. So So now let's continue. I try to balance my speed, but we have still have 140 to go. But we don't have to finish everything, so that's okay if we have to be slower, a little bit slower. Okay. So the next we want to do is besides price is important for our hotel booking. The other one important dimension is distance from the city center because we want to do a tourist visit. Okay. So what we want to do is look at the data, look at distance from the center. Okay. So the code will not be too much different from what we saw. We go line by line slowly because someone want me to slower. So again, what we do is we look at the hotel data. There's a column called distance, which is distance from the city center. So what we do is we use this square bracket to extract the distance column and save it in the distance. You can say whatever name, but we use distance to make our life easier. And because of if you try to look at data, distance is by mile. So 1 mile is very long, it's very far away already if you have to walk, right? Then they use 0.5 or 1 as a beam width, okay? And you can see there's the same code here, right? Just to create the beam to collect the information there, okay? Once you do this, you can see the same code, nothing new. Only difference between this and previously is instead of price, you have distance. And you have the X label is different. But let me go line by line. This again, the first line is to import the library that do the plotting called the matplotlib.py plot as plot. And because we just want to draw histogram is based on one variable, right? And you have to tell them how to group the data. The bins is equal to bins. Okay. So equal to bins here means the one we have this one. Okay. And this equal is I'm going to tell you this is how the Python you input. You input the bins. The bins is the option that will you input what kind of thing there. And usually for the Python coding, usually use the same name as what you input to avoid confusion. Of course, if you call this dogs, you change the dogs, that's also fine. You call it cat, it's also fine. But this is the same. This is the thing where you put the cat and dogs there. Okay. And then this is the graph. For the time, as I said, I just try to run this code instead of copying. This is the code there. So you can see if I use 0.5, this is the graph. Okay. Will be like this shape. Okay. Most of them is like within 2 miles from the city center. If you don't like this, you can make it 1 mile as we said in the slide. Change to 1. It will be somewhere like this. And look, the shape can tell us some story, what kind of data we are facing. Okay. Maybe if you think 8 miles or 4 miles a lot, then you cut out this data. Okay. So that's how what you're doing here is try to look at this data to screen out the thing you want to look at. Right. For example, I want to look at the hotel. I want to walk. Then at most is 2 miles. Right. And you cut all this thing. If you drive, maybe it's okay. You can maybe cut off to 8 or 10 maybe too much, maybe 6, right? So on and so forth. Depends on the data, depend on your purpose, you can cut the data. So that's why you look at histogram, because you want to see if you need to cut off the data. Okay, because you may not interested in at the end finding out a good hotel deal, which is very far away. Okay. This is 0.5, this is 1, we have set already. Okay. Now, once we have that, so we have focused on hotel. And the next thing is we decided we're going to a decent hotel. That means that we are going to the 3 and 4 stars, and 5 stars is a little bit more expensive. So we just forget about that. And then we want to look at the price again. So this is what we do is we are filtering observations. Okay, and we have actually done that in the last class, right? We filter data by looking at the manager that has played more than 18 games. Okay, we have done that. But let's look at that. So what we do is through the LOC function. I think now it's your friend. We have seen that many times already. LOC is tied to select observations. And you want to list out what are the criteria there. Okay. We start from the beginning, original data frame, the original data. You take it out, how to take it out? We look at the data where the hotel, star, number of stars more than or equal to 3, less than 4. Okay. And there's a problem if you just list 2. Because when it's missing, it is still true. So surprisingly, I don't know why, but Python is working this way. So you have to also put another one. It's not missing, not NA. Okay. Of course, if your data is perfect, you don't need this line. But if your data is missing, you add this line. Make sure that your data is not. And this and is the logical word and, which means that your data has to be hotel 3 and 4 star and no star, right? The star has to be there in order to be in your data. I call data cut. It's cut it out from your data set. Okay. So if you run this, then it will only leave us this what we want. Okay. These 2 criteria, hotel and 3 and 4 star. So the only key here is you do the screening at the same time. Okay. This is cutting the observation. Okay. And here is the other one is looking at, because I have cut the data, I want to look at the price again. Okay. Do the same thing because there's nothing new, but just set up 20 bins and so on and so forth. And I plot it again, right? This is what we have. Okay. So this is the data is filtered. Okay. Can you see the difference? I don't know, but this is a data that is, we clean up a little bit. Of course, I just use 2 criteria, and you can see you can easily add as many as you want. By using the and condition here, you can add as many as you want. Okay. And I guess I can just run it from here and here. Okay. This is a graph. Okay. So what I taught just now is just you can clean the import the data, you clean it up, and draw a diagram. Okay. And then you can keep changing this condition so that look at the shape. This is something fit what you think and what you want. You can present this out. Okay, this is, you have some idea. Okay, after the 3 and 4 star hotel looks like this kind of style. This is, you're happy. Okay. Is that okay? Yes. Oh, so the hotel cut. Sorry. Oh, that's why it's not the same. Okay. Okay, that's why it looks the. Oh, that should be this one. Fence. Oh, so now you can see. Oh, that's great. Once hotel cut, then you can see these all. Many of them are gone, but still surprising. There's a. I don't know what is this, but you can check the data. There's a also an expensive hotel. I don't know what's that one, but 1,000 US dollar per night. But thank you very much for pointing out the code. There's a missing cut here. Okay, this will be cut here. Okay. Is there any question about histogram? I know that is very easy for some of you, but I just to make sure that everyone who don't have prior knowledge on Python or missing the summer classes still can able to do it, because you can see whenever we do the code is very similar, right? It's not something that we have to reinvent the view. You understand this is the same code. We change the thing and then we get done. Okay, you can get it done. So it's not something like terribly difficult to do. Okay. Now under the graph of the graph, we want to talk about summary statistics by number. I mean, this is all the thing you would have seen that in the undergrad. Actually, I taught this morning. I mean, this afternoon I taught this in the first 2 weeks of our undergraduate class. But of course, I'm not asking you to take my undergraduate class, right? So, but anyway, I want to talk a little bit about what the function you can get it. I assume you have no problem with them, right? But just a quick recap. Mean is adding up all the observations divided by total of them, right? By construction, that is the middle by distance. It's where you look at the data, sum of the distance to the left of the mean and right on the mean. The distance to the left and the right are all equalized. Just to recap, it's just like this. I don't have time to go detail, but suppose you have a bunch of data here, okay? And you would say the mean is somewhere here. Why? The mean is somewhere here because you look at the distance to the left, which is all this blue distance, okay? Add together should be same as the distance to the right, okay? Maybe I should add more dots, right? So you add up the distance to the left and distance to the right, be the same. So it's the center by distance, okay? And median is exactly the middle guy, right? You order them from smallest to biggest, the exactly middle guy with the median, okay? Is center by location, right? And the mode will be center by frequency, right? You count, you look at them, basically just look at the bar chart or the histogram, look at the one that's highest height, right? That's the mode, right? And we have also percentiles and quantiles, right? Which tell me location, right? Percentile means, say, 50 percentile is the median, right? You can look at 25% percentile is a quartile 1, right? The 75 is a quartile 4. We look at where the data is, right? Basically, just like look at data, right? And the middle one will be the 50% and first 10%, 90%, those kind of idea, right? Is where the data is. And quartile is cutting them into 4 different parts. That's quart in English, right? Percent is divided by 100 parts. And this person is looking at how data is spread out, right? And for range is largest minus smallest, right? 90 to 10% percentile, looking at the top 90% and last 10%, and then look at the difference between this difference. And interquartile range, looking at 75 minus 25, right? And variance and standard deviation is something that probably you know very well from your class, right? Variance will be the average square distance from the mean. What it said is this distance, you square it. Every distance from the mean, you square it. And this square distance average of those is measuring how every observation different from the mean, right? And it's square because you don't want to distinguish positive negative, right? The larger this variance, the larger difference, right? The more spread out, okay? And lastly, the coefficient of variation will be just related to the standard deviation, right? Because standard deviation is just take a square root of the variance, right? And coefficient of variation is just dividing the standard deviation by the mean. This gives you this guy, right? And why you want to do this? The reason is compare across data set, right? For example, suppose our class had midterm. We don't, but suppose we had midterm. Then the midterm will be usually the marks from 0 to 50, right? For exam, we have 100 to 0 to 100, right? If you compare standard deviation and variance across exam and midterm, very normally, exam will have higher variance because the data have a large range, right? So for a fair comparison to say midterm and final, which one have more spread out, you have to divide the standard deviation by the mean. By doing so, you can easily compare variation across data set. Okay, and there's also a skewness and kurtosis. I'm not going to talk about those because there are two I guess it'll be too much for us. Okay. So is that okay? I guess it's just undergrad. I don't want to really just go in for that. But in case you don't learn the formula, AI is your friend, Wikipedia's friend is all there. That's the formula. We don't need to know how to use it, right? We don't really need to create a formula. But just to remind you, they're measuring the center, what they are. The main thing we discover in this class is we focus on mean and standard deviation. This is the main thing of class. Others, we will not use it again, but you know what the purpose they're serving. Okay. And here is the Python code to calculate mean and variance and all various things. Okay. But turned out to be, you can see it's not something complicated. Okay. Import statistics library. And I use the data I create 1, 2, 3, 4, 5, say, for example. Okay. And because I use the square bracket because this is how the way that how Python store data. Okay. And I don't have ST or whatever, so I have to spell the whole thing. Okay. If I import statistics as ST, then I just write ST. But I don't, I just write down the whole thing. So statistic.mean calculate mean, statistic.median calculate median, for mole calculate mole. Okay. And if you have more than one mole, then you use multi-mole. Okay. And max minus mean is the range. If you calculate quartile, IQR would be quartile number 4, number 2 minus quartile number 0. And you ask why 0? Because Python counting from 0. It's not counting from 1. So Python, the index is from 0, 1, 2, 3. It's not 1, 2, 3, 4. So that's how Python, many software, depend on different software. Some software count from 0, 1, 2, 3. Some software count from 1, 2, 3, 4, right? Human count from 1, 2, 3, 4. But historical or many software count from 0. Okay? So that's why 0 actually means 1, 2 means 3. And here we have the variance with p-variance and normal variance, Ph.D and normal SD. If you learn Excel, then you know what they are, right? Excel will have the var.p and var.s and stdv.p and stdv.s. Okay? And the difference between, just to remind you what difference between p-variance and sample variance is, one, the p-variance is divided by n, number of observation, and this is divided by n minus 1. Okay? And you may ask why I have two versions. Okay? I need to explain this. I actually will explain it in the next class. But I will tell you now why it's the case. It's because we always want to measure variance. Okay? It's something we want to measure in the population where variance is a nice measure, no doubt. But when you collect data, okay, you want to use the data, measure the variance to estimate what's going on in the big picture. Use the variance doesn't work. You have used the sample version. You divide by n minus 1. Okay? I often use this metaphor. Okay? Suppose 10 years ago, I have been married and I saw a beautiful lady over there. I want to talk to her, right? And if I go just directly, can you give me my phone number? Doesn't work, right? I probably get slapped and just doesn't work, right? So how do we go proceed? How we proceed? Go to Korean? No, suppose there's a beautiful lady here. You want to meet her and you say talk to her. So what do you say? Can you be my girlfriend? Or just say, does it work? Or can you marry me? Doesn't work, right? So it doesn't work in this way, right? You have to do some kind of gesture, right? Maybe flower, maybe doing something. Hi, how are you? This kind of thing to start, right? And maybe carry a dog around. I mean, there are many techniques, right? But you can't just go directly to say, okay, can I have your phone number? Doesn't work, right? Or you go now, these days, probably no one use phone, right? Now can say, give me your IG. Doesn't work, right? Right? So have to be some indirect. So that's, as same I said, right? So you estimate this from the data, the variance. You can't use the same formula. Often in statistics, when you want to estimate something from the data, you have to twist the formula a little bit to get to it. Okay, you cannot use a direct method. You have the indirect method. Use a direct method doesn't work, right? Suppose you want to meet this girl, you want to know her, but probably you would try to talk to her friend first, right? That's one way to do it. Okay, not to talk to her directly, right? Talk to her friends, and indirectly she will introduce her friend to you, then you're done, right? That is some way to do it. Or less fun is like many people play basketball, right? And unless you're Stephen Curry, you can aim for the ring, right? But you are aiming for the box, hoping for the rebounds to easy to get in. So I think that is another way to say, okay? So that is the statistics. And the other one I want to mention is NumPy. We mentioned this number. NumPy also have a very nice stat formula there. It's also mean, median, all this variance, SD. Okay, and if you use a sample one, you will have degree of freedom equal to 1, means you subtract that from 1. Okay, I don't want to explain that because this involves such a concept, but this is how you handle them. Okay. And finally, there's another package besides, sorry for many package, but you have to have many package to use it. Just like you have the phone, you have many apps, right? Only maybe in China, you have WeChat to do all the thing, right? But in other places in the world, you have many apps to do different things. So unfortunately, there's no single app to do all the thing. Same as this code, right? Elon Musk wants to have X to do everything, right? But so far, not successful. But this is a science PY, and I guess you also learned it from other class as well, because this is the package for machine learning. Okay, we use some of them in our class as well. But machine learning also have the mean, variance, skew, kurtosis, and also discrete statistics. But I'm not going into detail of that because I think you have learned it in your undergraduate high school. So if any question, I am happy to answer it. But I just quick here because just run this code, right? You can have the code here. You can just run it at home. You can have fun on that because I don't want to trouble you on this one. Okay. And the number we have what we call the 5-number summary, right? Which is the max, the median, the mean, Q1 and Q1 and Q3, right? This is the box plot, right? We often see this, right? Because this is the max, the mean, median, Q1 and Q3, right? And sometimes the violin plot even more sophisticated, because you will see this shape, right? This is a very nice way to see what the data is. So this is the maximum, this is minimum, this is the middle data, median, right? And this upper quarter of Q3 is median of you take this half, look at median again will be here, right? And this Q1 will be, look at this half, median of this lower half is here. And you also have this curve, it's lowering the height or the length of the width of this is look at how many data are there. So many data are here. So this, both the box plot and violin plot is very useful to see, to visualize what you want. And usually it's good to compare across data set. Okay. That's why what we do is to tell you that you can use the Seaborn library to draw a very nice box plot. Okay, I'll just show you. I'm not going to copy this code because it's so trivial. I'm not going to, but I'm going to explain line by line again. So first I have NumPy. Okay, why NumPy? Because modern Python, most of Python package would expect your data is either NumPy package, okay, or you are from the data from Panda. So either way, you'll be nicely data form you can do. So I have the NumPy, and I do the Matplotlib is a plotting library, and I said Seaborn will be the library that make nicer diagram. Okay, and I start the data is 1, 1, 2, 2, 3, 3, 4, 5, and I call NP array. Array is the way that the data is being list. Okay, list of data. Okay, and I do a very simple. Very simple. It's the C bond plot box plot X. Then you're done. So it's very simple. You can see already very nicely the box plot is there, right? The max, the mean, the median. This is the median of the upper half, and Q1 is middle of the second part. So this 25%, 75%, 50%, right? 0%, 100%. Okay, and for the volume plot, it's the same. You just change from the box plot here, change to the volume plot. Okay, and then you have very nice plot. Okay, looks like squats, but anyway, that's what it is. So now we are backing to the data. Okay, what we want is we compare different data set by the graph. What we want to do is look at London price hotel and Vienna price hotel. Okay, we're going to use the a bigger data set with hotel Europe price. Okay, and also a hotel Europe features, which contain two data set. Right, one is look at the price of this hotel and what the feature of this hotel. Okay, to data set, and we'll combine them. So we just redo what we do in topic one, combine data set, and look at the graphic. Okay, so up by now, I think you should be comfortable with this code. We've seen this many times, right? We have the NumPy is to handle computation, and Panda is to import data, and we tell them where to import the data and use the with CSV URL to get the data there and check the data. One thing, someone asked me where to get the data for your project, right? Here I magically write down the data, right? And you ask, okay, how can you do it for your project, right? So I just have to mention one website, which historically many students for many class would do it. It's called Kaggle. Maybe I just you search Kaggle is Google's friend, but I don't know whether they are friend or enemy. But anyway, there's Kaggle. I don't know how to spell, how to pronounce that. But this is the data science community that contains so many data. So what we're going to do is you go to this one, go to the data set, okay, and you will see they have so many data set here. You can have fun with that. So you can something crazy like crocodile data and GDP data is not very surprising. You have some weather data. You can Spotify data. Some people do Spotify. Some people do K-pop astrology. I mean, very surprising. I don't know why people still believe in those kind of stuff, but it was something as old as I am, people would do it. But anyway, so the football result, right? It's a many computer science thing, AI tools, housing price, and you can look what you do. There's many data here. See all, so you can basically type whatever you like. There, they should be there. If not, you can just collect it. Okay, and that should, I think, that should have enough data to fit what you want. And of course, CHK Library has a lot of data subscribed as well, so you can look at that as well. But I think there would be, this will be sufficient data for your purpose. Okay, just of course, you can always collect data by yourself if you want. Okay, because these days you can ask AI to collect data very quickly. So there are some AI website that basically say, you ask them something, they'll give you data, right? Or if it doesn't work, ask omnipotent Taobao. Okay, omnipotent Taobao can you pay some money, someone collect data for you. So you pay maybe 100 maybe 1,000 Hong Kong dollar, they can able to collect some data.
Not that much.
Huh?
Not that much.
No,
Not that much.
not but
More cheaper.
yeah, maybe cheaper. With $100 you can get a lot of data, maybe even cheaper. But I mean, if you need some particular data, they can download that for you. There are people who are willing to do the job for you. Okay, remember, you can just ask for data download, right? Not pay the money to do analysis for you. That will be violating the rule. Okay, asking for help for data collection, I think we can allow that. But if you pay for analysis, then you're violating the rule. Just to remember. So here we have the data, right? So what we do is we know that there's a price data. You read them. This is called the price, and you look at the data. Often you see when we download data, I always start with the head because look at the data what it looks like. Okay, here the data looks like this. Only the hotel ID, the price, date, time, year. That's it, right? Very normal thing. And I look at the features data. Okay, and this download from here. You run this. The feature data. It looks like each hotel ID, right? Tell you the details. There's no price on this one. Okay, this is only feature. So you can imagine this data collected, same for every other year, every days. But this collecting data is over time. Okay, because you just collect the ID and the price, right? Same ID can have different, same hotel have different price over different days. Okay, and the first thing to do for our exercise is to combine data, right? Because we want the price and feature together. So the merge, remember when you merge data, we have some unique ID, right? And want to remind you that this is not one-to-one merge, right? It's many-to-one merge because each ID, hotel ID, will have only one line. And remember, in our price is one ID can have many prices, right? So that is a many-to-one merge. Okay, and okay, so what we want is have a special type of merge. It's called the left merge because we want how well the merge is for this. Every observation would be merging the feature append to here, right? So this merge from the left-hand side. Okay, if you want to only merge the first item to that, use the right. But you want every row from here merge to here. In Python, it's called the left merging method. So that's why. Don't ask me why left and right, but this is how they define it. Okay, I don't really know, but they call if you want everything from one to the other, right? It's called the everything feature map to that is called the left merge. Okay, and how you merge is based on the hotel ID. Okay, use the merge pandas function. Remember, panda is the handling data. Okay, you stop merging these two things with data set together. And once I did it, this is optional. If you don't want it appear in your memory, you can delete them. Okay, because you import from there, you can delete them or you can keep them. Okay, this line is optional. Okay, if you don't like delete, you want to keep everything. Okay, then you can keep there. Okay. So once you do it, you want to compare two cities only. Okay, because this data contain Europe, so we want to keep the two cities. So we want to keep Vienna and London. We filter them out and keep them, and we want to keep on the same year and same month and take out the weekend. Okay, that's a weekday. We go to weekday trip, and we look at the 3 and 4 star hotel, and we want to look at the price that is not too crazy, below 600. Okay. So how do we do it? You can see a homogeneous stuff there. So let me go line by line. You see what I'm doing. So look at the hotel data. I focus on the year 2017. Look at November, not weekend. Here is a little bit tricky part here. Look at the city. Okay. I look at it is in either Vienna or London. Okay, so this is a very inconvenient thing is in. But of course, you're old guy, then you probably would do an OR thing, right? Hotel OR. You can use the OR thing, but this is more readable, right? Instead of using an or statement, you use an hotel is either in there. Of course, if more you want to say include Paris, then it can also more. But this is a very convenient, right? Rather than another line there. So is in is a very convenient thing. And you keep the hotel in 3 and 4 star hotel. We have seen that already. And not NA, we have mentioned NA will fail this, will say true always. Okay. And also here's another one. That's called city actual. It's because of city is a very generic term. Okay. And just like probably many of you have been to Shanghai, right? Shanghai originally is very small, right? But they expand a lot, then Shanghai become very big. So everything becomes Shanghai. So same idea here, right? Vienna, London is very big, right? We want to look at it. Actually, it's actually in Vienna, actually London, right? So it's not something too far away, right? And price is less than 600. So that's how we do, right? Remember what we do is LOC is selecting observation. So I hope now it's clear what this code is doing. Okay. So don't worry, you will produce something similar for your assignment. So you will know how to do it. So don't worry about too much about, you don't have practice, or you will have practice. Okay. So the next going to do is we want to look at Vienna and London. So what you're going to do is you take out, again, LOC that. Look at the Vienna, save as Vienna. Look at Vienna price, V price. Okay. And then you want to plot a histogram. And this code, the similar what I've seen, right? The same code here, right? So I'm not going to go over that, right? And here I have histogram. The only thing new is the density true. Okay. If you don't say true, it's always false by construction. But when you say true, it becomes the relative frequency. As I said, what frequency is become percentage, not the absolute count. Okay. So everything the same, except I add a new thing, true. If you don't have that, it's always false. Okay. The only right, this is everything the same. I'm not going to repeat that. So once you do that, you can see the frequency become relative one. But we enjoy the shape. Okay, here. There's a Vienna diagram. And you can do the same looking at, instead of Vienna, look at London. Okay, using arrows to cut it out. And do the same. I'm not going to go for the same code again. So again, of density true. Look at London price here. Okay. So this is the same. So you can easily see the shape. London is super expensive compared to Vienna, right? Because the shape on Vienna is look like this, right? But the London is like, ooh, very expensive. Okay. So this is the two thing, right? But of course, you want to do a side-by-side plot to show how they're different. Okay. So that's what we do. Instead of having a two different plot, okay, this one and this one, we want to put it in the same plot and using the same bins. Okay. So what we will do is use a function called subplot. Okay. Very often subplot will allow us to plot two plots at the same. Okay. That's what we do, subplot. So first, no different. I use the bin there. Okay. And how to count the bin is just use the original hotel cut price, minimum, maximum, look at bin width, the same thing. So the new thing is this guy. Okay. I create a figure with two subplot. Okay. So this is new thing. And this is usually actually you will see in the standard way people do the plot. Okay. You have a figure and tell me the axis. Okay. And I create a subplot with one row and two column because I want it to side by side. If you want up and down, will be 2, 1. Right? How many row, how many column? And figure size is depend on what you like, right? It's just you can just change this number to make it different shape, but this is 12 by 5. 12 by 5. Okay. And once you declare that, you have to tell them, okay, you have two axes, right? You tell them the first one is what, the second one is what. Okay. The first one, the plot is Vienna. So you can see that not much different. Instead of plot dot hist, I have axis 1 dot histogram. The rest are the same. Okay. And the only thing difference here, a little bit slightly different, is some cosmetic thing. I have alpha 0.5. Those who play one micro Photoshop will know alpha is. Alpha is the transparency. 0.5 is half of them a transparent color. And I use the blue color histogram. Okay. And the rest were the same. Just instead of plot is axis now. SS1, X1 dot, okay, the same thing. Okay. And London the same thing, right? X2. And then London, and then I use the green color. Okay. Once I do that, I use the plot and tightly, I'll make it very tight. So you will see these two diagrams. Okay. Just side by side. Okay. Because I said by 1 by 2, right? So 1 row, 2 columns. If you want up and down, would be reverse it, 2, 1, right? If you can easily plot very complicated plot, right? You can put a grid because you want 3, also doable. You want how many grid, that's also doable. So it's a very flexible thing, right? If you do things in Excel, you'll be a nightmare, right? You can easily see Python is very convenient, right? Because no matter how many hotel, how many location you want, you can easily plot it without problem. Okay. So let me finish one more slide and then one more diagram, then we will break. Go very quickly. So instead of histogram, okay, it doesn't seem to be very clear because it's still up and down. Very often we would what we plot is called density plot. Basically, it's just like taking out the top part, you just write a line there. Okay. And luckily, it's much easier. So you can just use the C-bond. They call the KD plot. Okay. You just tell them SNS dot KD plot, SNS KD plot 2 prices. Okay. And then C-bond will create this directly. So that's why C-bond is simplify your code. Right? Remember Matplotlib, how many things you have done? You have to do this many lines, right? But for this density plot, you can quickly see, okay, this is the Vienna, and this is London, right? Quickly you will see what's going on there. Okay, and I should stop here for a break of 15 minutes. Or maybe cut it off 10 minutes, right? It's okay. We resume at 8:45.你 create 嗰陣時，你可以改呢個名佢飛過。喂，呢個喺你個 screen 裏邊點講？我機會唔做，你飛喺 screen 喺你咁，你幫你自己交叉。係3嘅。都能頭，佢根據佢有個嘢喺度，跟住 I 方人就寫好嗰個。
係 responsible 嘅 screen，所以佢之前俾狗啊、沙皮食啊，但係你做都係出心嘅，因為個場嗰啲嘢俾嗰啲係個都係開都好難好難都有因為係join 就 join。然後咧，如果你寫咧，每一邊嘅每一格都勁過，因為可以孭個名，但係當然正常嚟講咧係真係多一係一嘢一係我哋好少時間。如果你係除非係啲好有啲好神嘅理頭先講，所以我哋教你正常你諗到啦，可能教而家教呢個對大家覺得我快啊，我覺得我快嘅，你咪覺得我快嘅如果佢真係冇諗到真係，佢真係唔覺得我快，佢話快我都覺得慢啊，佢邊話我快我都好無聊嘅，頭先話啊係咪好難教啊？你覺得？係咪快？如果你，所以我成日都問你哋覺得我快嘅。書法世界係差唔多嘅，你啊打一堂就逼你前話聽人咁我得加咗 friend 你決定咗啦，已經唔係你都幾多你交數？我自己想講啲啊，我自己想經歷而家應該唔使咯，我回嘅喎。呢個天氣關係冇得唔死㗎。你如果有咁嘅先可能我哋
So I try to see how. Want to say? Anyone to say something? Let me end in 1 minute. 10分鐘俾你去攞啊！Hi. Okay, not too fast. Can we go enough? Yes, definitely. No one should leave earlier or later than that one. Yes, I think if you haven't do the Python, then probably you need to have some time to digest. But the code, you can see we are just recycling the same thing. So I think you have, if you want, you can run it. But as I said, you are assigned assignment. Then I think first one assignment will be, I think, end of next week. Maybe next week we'll have assignment. I think next week, right? Next week. It should be next week. Very good question. Let me check quickly. My sign. When we finish the first 3 set of slides, so probably it will be released, I guess, by the end of the month. You have, I think you have two weeks to do so. At least 10 days. So shouldn't be an issue. But I will ask what should be the appropriate deadline, because I know you guys are very busy. So we'll figure out what to do. But I think we will have I know you guys are busy, so I will just have 2 assignments, and just 2 assignments. The last one will be optional. Optional in the sense that I assign it, then when the times end, I just release the answer. You can just do it for your own check. So it means that you want to do it, you want to do it, you don't want to do it, you don't want to do it, it's fine. We are not grading for that one. Of course, if you want me to make a free formal assignment, I can do that. It's not a problem. Okay. Start thinking the life decision I've made, learning started at 9 p.m. I guess that is something I think it's worth it. The last question is tricks to chasing girls for Master Sifu. Okay. I don't think I'm expert in that, but I think your classmate are expert in that. I mean, the data claim, yes, you use your own CSK email to log in because the free account, education account will be linked to your email address. And it can still be accessible 3 months after the class is over. So it will be, I think it will end in next, I think April. So it should be sufficient for the purpose. You can learn Python out on that. Highly recommend if you want to learn further from what I did in the class. One thing I want to mention is about the timing of the presentation. And many of you said, I mean, they have to go out. I mean, but I think the timing of the presentation will be drawn next class after SOP is over. So probably next class, I will open a spreadsheet. You can tell me which group you are in, right? And we'll draw based on the group. So we'll do a lottery. And you can tell me you want 2 days, one of the day, you can pick it up, okay? I'm thinking like you will be presenting each member will be presenting maybe 3 to 4 minutes at most and max. So if one person group, you present 3 minutes, 2% 6 minutes. You don't have everyone to represent. You can pick up one guy who is very talkative, very well presented to talk everything, right? That's okay. And that means if you have multiple person group that and you can delegate to one guy, right? That's okay. Right? I don't mind that because you guys in the industry already. So presentation is something that you know how to do. I mean, I know to train it, but I just want it to be a learning practice as because you need to present and people know what you're doing. We comment it. And also the presentation is peer evaluate is part of the assessment. Right. So I mean, if you are dedicated to that guy, then you take all the risk, okay? He didn't do it right, then you blame him, okay? Not blame me, okay? Because it's none of my business, okay? So I guess because of time, I'm skipping this one line code thing. But I want to still keep talking about the last one. It's called the describe. It's very useful function, summary statistics, okay? Because it gives you the mean, median, mode, this kind of stuff. So what to do is very simple. You just use the data set and do dot describe, already you're done. Okay, but this is I want to compare two data set. So that's what I do is I save the describe the thing into the called L sum, and this is called V sum, and I combine together in the same data set. Okay, and once I do it, it will come up very nicely in this way, where I will see how many data are there, right? London have N is like this, Vienna is like this, this is the mean, this is SD, there's a minimum, the maximum, the median, 25 and 75. So this is usually how you would let you see the data is. Okay, but of course, this number, but if you don't like the number already, the graph actually tell you most of the thing already, right? Where the mean 25, I think, can be very nicely seen. Okay. And the other one is use the group by. We learned in last class, last slide. It's aggregate and do many ways to do because describe just allow you to do this, right? But you sometimes want more, and we need to use what we call lambda function, which is very advanced idea from pandas is to allow you to do many things. But let me show you because it's a little bit complicated. Okay. First, what I do is I look at data cut. I group by city, and look at the price describe means I group data by city. I look at the price, I describe it. Okay. By doing so, this code will allow me to group by the city, and this city level, I create this. So you can see the code is much simpler because one line, I'm done. So basically, this is the one line code to create summary statistics, right? Say you group by different level, is the price and describe, right? Because you don't want to do this, then everything will be done in a one line, right? There's no by city level, right? But usually this is where you group the data by, okay? And here is an little bit more complicated. Is describe is the thing that is tell you only have these columns. But if you want more columns, you will do the aggregate that we have seen before. Aggregate is trying to tell you that you can do many stuff. And aggregate can allow you to do count, mean, SD, mean, median, max, and the range. Okay, you can put any function. But you can also do the lambda x. It's called the lambda function in the NumPy package. Then you can use lambda x and do the quartile or the skew. You can do many things. You can tell this very interesting function there. But for the moment, this will be okay, I guess. Again, nowadays, AI is very convenient. If you don't know what the lambda function we want to add, you can just ask AI. They can do it quite quickly. You can just add this. You can tell them, okay, you copy this code to your AI and ask them, I want to add a column of, say, whatever measure you want, and he will add it for you, right? Because you ask AI from scratch, usually they give you a bunch of rubbish. But you give him copy this code to the AI and ask them to add something, it will be easy to do. Okay. By saying that, I'm not saying that in your assignment you can do that. It's better not to do it. But I mean, I can't check, but anyway. I think last year some people actually did that because they all make the same mistake. So I guess you should check the code before you just submit. Don't just basically copy my code and just copy my instruction and just do it. There will be some mistake in the code. But anyway, not everyone. There's some people did made the mistake. But so I guess you can try to see if you can change the code, and finally because the name you can do rename the column so that look nicer. But otherwise, don't worry about this. Okay. And here's some technical thing about probability. I excuse you from this crazy thing. So you can see the pink color thing. I'm not going to talk about what is probability, what's random variable, what is the different kind of distribution. I spare you those. But we'll mention the thing we need when we face them. So, but I just skip this at the moment. If you learn statistics in undergrad, you should have seen it before, but I just exempt you from that. Okay. But later we still need the bell curve. We'll still talk about that. The bell curve, the normal distribution. We'll still talk about that. But don't worry, we'll remind you exactly what you need when you go there. Okay. But I don't want to cover things you may not need it, so I just keep it. Okay. So don't worry, when we skip things, it's not in the exam. And if I'm slow, I don't cover everything, then it's okay. Those things are not covered in the exam, right? And the notes are all there, so you can check it out. I think my notes are pretty detailed, so even if you can read it, you can understand if you spend some time. So shouldn't be an issue there. So now we are the last half hour, we go to comparison and correlation, which we enter into more useful thing. So far has been just reviewing things, so we enter some serious business, right? So far just like something undergrad thing, right? So more interesting thing. So association, and I guess when we want to make business decision, we want to before we make a decision, we want to have data to support our decision, right? We want to why we take this, not the other, right? Must be from data showing that this option better than others, right? So we need some causal effect, right? But if you don't have causality, at least we show doing this usually associated with something nice, right? So for example, why you study master degree? Why you're here?
So much leisure time.
So much leisure time. Okay, very good to learn statistics at 9 a.m. So why are you here, right? I guess beside academic curiosity, I guess you want to what? You want to make more money, I guess, or to improve yourself, right? I mean, or get a master degree, right? For whatever reason. But we want this change of your degree to lead to some change of something, either person improvement, right? Make yourself happy, right? Maybe meet some beautiful girl, right? Or classmate, right? Or have some fun here, some changes in our life, right? So, and the thing is, X is what we can change or we want to change, and Y is the outcome, right? So in our class, we will study two things, okay? One is based on change in X, is it going to predict change in Y? So it's association question, right? Is studying the master degree lead to higher income, right? So that's what we want. At least we want to study the master degree. If you look at the master after the degree, people get lower income. Probably you don't want to come here, right? The first establish the first thing is having a master degree does not reduce your income, right? That's the first thing to do is association, right? At least this predict a degree will predict you higher income, okay? But it doesn't imply having a master degree will increase your income, right? Because maybe something like only those people who is likely to get promoted, okay, who come to here to get a validate and promote, right? And in that case, studying a master degree doesn't help, right? Because if the people who actually enter a degree are about to promote, then you are a random guy coming to here doesn't get a promotion, right? So the causality can go the other way around, right? Those people who actually can get promoted actually come to here, right? Then there's the other way around. So it's not going to be within the prediction. As I said, so far in the first class, so far in AI, what we have seen is all prediction, okay? And all the machine learning now is all prediction, okay? All the things you learn, okay? And that's also you learn other class as well, right? And that's why the second half of a class, we will do causality, okay? By making some assumption, we know some knowledge about what's going on, okay? Then we can establish the causality, okay? What is the easiest way to establish causality is experiment, okay? Suppose I am a crazy ruler in the world. What I'm going to do is I randomly pick up some people, okay, to join the master program, okay? They have to come. If they come, I just shoot them, right? They have to come. Then I can compare those who come and those who don't come. But those who take the master, who don't take the master, then that will be the effect, okay? And that's what happened, right? You may laugh, but that's what happened in the lab for medicine, right? We give the medicine to mouse, right? You take the medicine, right? Some mouse die, some mouse don't die, right? Then you see the effect, right? We infect the mouse and serve the medicine, right? And some of them recover, some of them don't recover. That's how we test the thing, right? Then we are crazy dictator for the animal world, right? The same thing happened here. But now we are looking at the goal number one, okay? We'll look at goal number 2 for second half of class. So how do we look at it is what we call holding out that thing constant, right? The one way is called conditioning, and the key we look at it is we call this expectation. What we expected means average value of y given x. Okay. And for example, is looking at the average salary without the master and average salary with the master, and look at the difference between the two is the correlation. Okay. That's we see how x changes relate to these changes. That is called the association. And to show association, there are many ways. Okay, you can do scatter plot, box plot, group box plot, mean and covariance. We will do all of them. Okay, not sure we can do everything today, but at least in the next class we'll do all of them. Okay. So we will do is the management data. As we said, it's a wealth management survey. Okay, looking at I think it's more than 10,000 firms, and looking at them is a very nice data set. Okay, so this download from there, the data is here. So just remember from that is there's a management quality. Look at your manager. There are many good practice and bad practice. Okay, and management score will be average 18 score on different practice. Okay, and the key question here is asking is how the management score with the firm size. What's your take? Okay, is bigger firm has better management, or smaller firm has worse management? What do you think? Is big firm better or smaller firm better? What will you say?
No relation.
No relation. What will you say? No relation. What do you think? Is it better firm better or smaller firm better? No, you think no difference? Depend on people. But on average, on data, right? That's of course everything depends on average, but on average, you think that bigger firm is better managed or smaller firm is better managed? Bigger firm better managed, right? Smaller firm less. The reason usually is like bigger firm also you have more specialized manager, right? Rather than small firm, you have less hierarchy, right? So, but we will see the data very soon, quickly, and see what you said is probably right, but you will see the data. So here the data is a lot, so we focus on Mexico, okay? And look at year is 2013. Look at the company, not too large, is 100 to 5,000. And number of firm is 300, okay? Remember, we look at two things, management score and firm size. Look at how they're related, okay? And of course, we start with the exploratory data analysis. Look at histogram, right? That's what we do last class, right? The data is clean already because this data from the database, so we don't need to worry about cleaning, okay? We still have to get the data and filter this out, okay? So our old friend is here, Panda, okay? Import Panda as PD, and we have NumPy because we have to do the plot, we have to create the bins. That's why we have NumPy. And we start with the URL, our old friend Panda, read the CSV, and show the data. Okay? I hope this is now you very familiar with this by now. So this is a data set, right? Look at the firm ID, which year they survey them, the city, and city name, SIC is the industry, management score, and this management score is an average of many of the 18 score there, but this is the I think this is the average of the 18 dimension of them. Okay, so we are looking at that. Okay, and we're looking at the people, compare I think number of people across the management, if I remember correctly. So first, our old friend as well have seen LOC, right? LOC is what? Selecting observations. Okay, we're going to select the observation from Mexico and from 2013 wave, and the employment of the firm, number of the worker is more than 100 and less than 5,000. Okay, Here you note that I don't have not NA because firm must have some employee, so you don't have to worry about that part, right? So you don't have the NA thing. So that's pretty much done. Okay. And here I have the project management score. Okay. So I look at the Matplotlib, the plotting library. We have known this already. And I want the management score only, right? As I said, this is the 18 average of different management practice, the score. Now here comes a little bit tricky part, okay? It's MP range. You start from the first number is 1 because the lowest is 1, okay? And because average of 18 score, so although score is 1, 2, 3, 4, 5, average of 18 you can be any decimal number, right? Can be anything from 1 to 5, maybe 1.25 is also possible, right? Depending on what number. And I decide the bin width is 0.25. Okay, a quarter, you can do any number, but I pick the number is 0.25. But here look at because of the way the Python done, you have to add the last one because this is the last one. Okay, because the 5 will be 5 to 5.205. So this is, we have seen already this guy. Right? Why add this is actually we have done this all the time. If you still remember when we plot the thing in the bin. Oh, sorry, I have to go all the way up. We have the mean, the max plus the bin width. The bin width here is 0.25. So that is 5 plus 0.25. Why we do that? This is just the Python artifact. Okay. It will be maybe disappear sometime soon, but we still have to use it because the way the Python. I mean, don't ask me this. Someone who make this code have to go to God suffer, but they make us suffer from this code. But anyway, I mean, they should have more smart way than everyone. Every time we have to do this, but at the moment, if we have to do Python, we have to deal with that. So they should have done that, but that's a very important. If you forget about it, the 5 score, the score that is actually 5 will be disappear. So make sure that you have that. And this is histogram, right? And the score and the bin come from here. And then it's true because I want to look at the relative frequency, the percentage there, and X label, Y label, and so, right? Nothing new there. So look at this, right? This is score on average, look at this one. Okay, nothing surprising, but you don't have the worst case 1, but you don't have the best case 5 as well, but it looks low. So this is score. The next thing is look at the firm size, look at employment. The same thing goes on, right? Look at the employment, says there. The only difficulty is look at 0 to 5,000. Okay, and remember the bin size is 200, so you add the 200 here. Okay, and everything goes on the same. Okay, I'm not going to repeat that because it's too trivial. Okay, so this looks like, right? So the score is more like a bell shape, but the employment you can see most of them are less than 1,000. It's skewed to the right hand side, right skew, right? The data is all here. Okay, so that is the thing that you look at the data first time. So the question is whether you keep this data or you would do something else. But let's keep what it is. We'll see how we do analysis. Okay, so this is EDA, right? The EDA tell us you can calculate data. What's the mean? What's the median? What's the difference? I will show you immediately. And we can look at the firm size, those mean and median, okay, as well. So to calculate them, it's very simple. You can do the NP, the NumPy package, NumPy.mean, NumPy.median, NumPy.SD. The score is the management score. The employment is what we get it from there, right? So this is to report. You calculate this and you can report this number, right? That's how you get the data and report the summary statistics, right? Of course, your boss don't want to see this, right? I mean, don't only want to see that by showing you, okay? So, but this is the thing behind this data, okay? Now, ask, remember our question, okay? One of the question is, we focus on particular management practice. It's called the lean practice. Is it whether the management is very bureaucratic, right? Do a lot of crazy stuff, right? So how lean they are, right? And the score is 1, 2, 3, 4, 5. And we just ask an even simple question, not the overall score, but asking, is a large firm having a better lean score? That's it. Okay. And first thing to do is have a scatter plot to have an idea. Okay. And so far we have done any scatter plot. So we do a scatter plot. And we will do a lot of scatter plot for the throughout the semester because we want to study cause and effect. Scatter plot is often the first thing we want to do to show how they're related. Okay. So nothing very deep here. Okay. You can see I have a matplotlib, an old friend to the plot. I call this X and this Y. You can swap, but because I like in this way. So here only thing is change this thing, use the scatter plot. Okay, X and Y. And X is the employment firm size, Y is the management score. And once you plot it, look like this. So you can tell, is it better firm? Is a bigger firm better? Seems to what you say is correct, right? You go to see the bigger firm seems to be better, right? Because the worst firm has a lot of variation. But when you go into a bigger firm, it's getting a better score. Okay? You actually fit our intuition, right? It's good to work in bigger company, right? You can lie down, right? Easily, right? Because there are many people there, right? It's not easy to discover. But if you are in small company, then if you're not working, you're sleeping somewhere, then it's easily discoverable, right? So that is the idea. Okay. But of course, if you try to look at it, it's not entirely clear there's a trend, but it seems to be because you can always plot in this way, or you can plot in the other way around. It's going to be a flat, right? It's not entirely clear which one fit better. Although seems to be the case, right? So it seems to be the case. So how can we solve this kind of problem, right? The scatter plot doesn't show very clearly, although turn out to be right, but we'll show you. Is by creating beans, group the firms together, because looking at this is hard to see, okay? But by grouping them together, make our life better. So let's see this, okay? Suppose I group them in this way. From 100 to 200, cost small firm. 200 to 1,000 or 999 is medium. Above 1,000 is 72, okay? And you ask me why I do that, but okay, just accept there's some way to cut the data in this way, okay? And you can calculate, which will show you the code. If you do this, the average score of small is 2.6. The medium type is 2.68, but the large one is 3.1. So by looking at this, at least there's some evidence, not quite there yet, but at least there's some trend you can see. Maybe small and medium are similar, but at least the large is better. Okay, of course, I didn't show you that. Those of you who know statistics will ask me, where is the SD? Okay, I haven't do it yet, but at least the mean showed it. SD is not there yet, but SD we will talk about in the next set of class. But this class, we forget about SD. Okay, just the mean. Okay, we don't talk about standard deviation yet. So how we can get this thing? Okay, what we're going to do? Oh, this start to be complicated. Sorry, but I think it's good to end today with this complicated code. It'll be nice, and then you can have a good rest, have a good dream. So what we're going to do is to create a new column. Okay, we call the employment free beans. Okay, and we start with NAN is nothing there. And what we try to do is we will say if the employment of the firm less than 200, I will set this column to 1. Okay, if you know Excel, it's just if statement. So if this is less than 200, it's to 1, otherwise NA. So if you know Excel, that's it. Very simple idea. Here, we do the same thing is look at the observation. If this is between 200 and but less than 1,000, I set to 2. And then it's more than 1,000, I set to 3. So nothing very deep. Just basically, I just code them. If less than 200, I call it 1. 200 to 1,000, call it 2. More than 1,000, call it 3. Just what the code is. But logically become this. I mean, that's crazy. But if you learn programming, that is something very natural to do. Right? If you do Excel, it's also the same thing. Okay? Once you do it, you want to do counts, right? The counts will tell you, as we have seen, how many in the 1, how many 2, how many 3. That's the data we gave you. Okay? And once you do it, we can use our old friend group by, because that's how we calculate, right? Group by this thing, okay? And we calculate the mean score. Okay. So it turned out that it's like the mean is like this, as we have seen. So that is supporting the data. So it's a group by to do that. Okay. Now, still you would say the mean doesn't help a lot. You want to see the whole thing, right? So just the mean higher doesn't mean anything, right? Because it's distorted by outlier. So you want to see the whole distribution. So that's why we will show you this graph before we go. Is we want to show you very complicated thing. And this is the graph we don't see. Okay. This the graph is small, big, medium, or large firm. And blue is the 1 score, and purple is the 5. 5, 4, 3, 2, 1. So here we show that from this diagram, where clearly large firm is better, have more higher score. Lower score are more in the smaller firm. Okay, so this is how we want to draw. Okay, and I want to show you how we can create that one for the last 7 minutes. Okay, so shouldn't be too difficult, so don't worry about it. Just a few more slides. Okay, so what we're going to do now is I only want 2 numbers there, right? I only need the filter. I only get the bins, which is 1, 2, 3, right? Because whether they're small, medium, or big, right? Empty 3 bins we created, right? And this is the number of score, right? 1, 2, 3, 4, 5. Management score. So what we're going to do is we want to calculate the number, right? Only the number matter. How many firms there belong to each score. So that's what we're going to do is I use the data set, I group by, okay, looking at these scores, okay, for each bin, each lean value, okay, I count, okay, how many of them belong to each bin, okay, and I reset the index. So what you're going to do is like this, okay. It means that for each, you group by these 2, right? For each small, medium, or large, okay, for each value, I calculate how many of them. So it's actually the pivot table idea, kind of, right? So I count that. But the way we do is a group by this. Means I have this, these 2 columns, which goes on there. And I aggregate means I add them up, okay? By size, count how many of them, okay? I count them, okay? That's give you this column. So that means that for small company, there are 14 of them has a score of 1, 27 of them 2, 23 or 3, so on and so forth. Okay. By doing this, I can do the plot because I only care about the number of firms. That's the data I need, right? Once of this data, okay, I need one more item, then I'm done. I need to calculate for each set of firms, how many of them. So I want to calculate small firm, how many things in total. Okay, so that's what I'm doing is I group by firm size, small, medium, large. I look at the count because the last column I create, count is the last column I create. Remember, this is the count. I look at the last column I create. I use a interesting function called transform.sum. Means that I take out the sum. Okay. And it called group count. So what I do is I create a new data set, right? That's tell me that I have 702 here, okay? 156 here, right? So that means that I actually calculate this, becomes 702. 72, 72, 72, 72, 72, 72. This. Okay. Why I do that? Okay. Okay. Once I do that, okay, I can calculate percentage because I care about relative frequency. Right? Because the three groups are not equal size. So we can easily compare. So I only care about relative frequency when I do the stat plot, right? Because remember, we want to draw this as a relative frequency. And remember, this has 156 firms, these two have 72. So for this comparison to be reasonable, you have to normalize by the number in the group. Okay? So that's why in the next step, I do is to calculate percentage, which I do the count over the group count, which is in the group. How many firms do you have? 100%. Multiply by 100. You have the percentage. Okay. So that's what I get here, percentage. Okay. And the following is just to a technical thing, just to change the variable to categorical data so that it can plot nicely. So nothing very deep here. Is I have the lean score, okay, and I want to declare that as a categorical variable. Means I no longer care about 1, 2, 3, 4, 5. 1 is something called 1. 2 is something called 2. It's no longer called 2. Categorical means the number doesn't really matter anymore. 1 is called something 1. 2 is called something 2. 3 something 3 is no longer a number. Okay. 3 is just the name 3. Okay. That's what it's doing. Okay. And for a solid, same as we call this, we just change it to categorical variable. Just I no longer have a number there. It becomes just a name, just an English name. 1 is just the character 1. I hope that makes sense to you. Okay. Once we do that, I mean nothing will change in the data. Okay. Then because of the name here, for simplicity, I call 1 is small, 2 is medium, 3 is large. Okay. I replace means I don't like 1, 2, 3. I want to call 1 is called small. 2 is called medium, 3 is called large. Okay. Once I do that, it's cosmetic. Okay. Nothing changes as well, but you can see 1, 2, 3 becomes small, medium, large. Okay. And now it's almost done. Last step. So just 1 more minute. So it just have 1. I do a pivot. Okay. Pivot table. I index this. I change the column. And percentage, this is what you see in the pivot table in Excel. Okay. What it do is it will allow you to have this table. And this table allow me to what we call a plot. It got stack the bar. Use the plot function, okay, in the NumPy, and you get this graph. Okay, and as I said, It's still 9:30. So 31. So bye bye. So I will see you next week.